Welcome to this video on how to change any equation into slope-intercept form. Remember, slope-intercept form means y equals mx plus b. X and y are variables, and they will always stay there. They don't get replaced with numbers. M represents the slope of the equation, and b is the y value of the y-intercept. In previous videos, we talked about how when you have an equation in slope-intercept form, that's one of the easier ways to graph an equation. However, what do you do if you're given an equation but it's not in slope-intercept form? Well, let's do a few examples where you're actually given an equation in standard form. So standard form looks like ax plus by equals c. I'll show you what I mean. So let's say we have the equation x plus 10y equals 36. Or if you want, you can rewrite it as 1x plus 10y equals 36. So how do we approach this? So it's important to remember anytime you're doing any kind of math, what is your goal? Where are we going with this, and what are we trying to do? So our ultimate goal is that we want something that looks like y equals mx plus b. So notice here that y is all by itself on one side of the equation. Y has been isolated. So that's exactly what we're going to do. This process is very similar to solving an equation. Think back to 1.1 when we were solving for a variable, right? We moved everything away from that variable so that it was all by itself on one side of the equation. So I'm going to color y in red here to remind ourselves that that's what we're trying to do. The y is going to stay exactly where he is, and everything else is going to move away from him. So another thing that I like to do, you might remember this from a previous video, I always draw a vertical line here so I don't get my two sides switched up. Okay, so the first thing I want to do is I want to subtract 1x from both sides. Remember that 36 and negative 1x are not like terms, so we cannot combine them. So we bring down the 10y, we have 10y equals negative 1x plus 36. Now let's just pause for a moment here and ask a question. You might be thinking, Professor, why did you write negative 1x plus 36 instead of 36 minus 1x? If it were me, I would have written 36 minus 1x. Well, that's totally fine if you want to do that first. However, I'm lazy. I like to skip steps, and my goal, right, is to have something that looks like mx plus b, not b plus mx. So if I go ahead and write the x term first, and then the constant, the b, second, then it just saves me an extra step. Again, if you're more comfortable, or if that weirds you out, if you're more comfortable doing 36 minus 1x first, and then taking an extra step to rearrange it so that the mx, the negative 1x is first, and then the constant is second, you're more than welcome to do that. Or you could even do it at the end. This is just the way I do it to save myself some time and energy. Okay, so notice that y is almost all by itself, but it still has a 10 sitting next to it. We have 10 times y, and the way we undo a times 10 is dividing by 10. So if I divide that side by 10, I have to also divide every single thing over here by 10. So we have y equals negative 1/10 x, and then 36 over 10, we have 2 going into both numbers, so we can reduce that to 18 over 5. You could also write it as y equals negative 1 over 10x plus 3.6. Okay, remember in general in this course we prefer to keep values in improper fractions. So this would be the preferred answer, but mathematically this is also correct. Okay, so notice that we have achieved our goal, right? Our goal was to isolate y, to get it all by itself on one side. And let's just take a moment to admire and bask in the glory of our accomplishment, right? Because of this accomplishment, I can now pick out the fact that the slope is negative 1/10, right? And that my y-intercept would be the point 0, 3.6, right? Because that's the y value of the y-intercept. So if I wanted to graph this, I could start by graphing the y-intercept, and then I could use the slope to generate more points. All right, let's do another example. Here we have 7x minus 3y equals 27. Again, I like to always remember my goal. What am I trying to do? Well, I'm trying to get y all by itself on one side of the equation. So the first thing I'm going to do is I'm going to draw a vertical line here so I don't get my two sides mixed up. And again, this process should feel very familiar because it's very much like the process we used in 1.1 to isolate a variable. Okay, so again, I encourage you to remember we're not moving y, we're leaving y exactly where he is, we're moving everything else around him. Okay, so let's look at the sign in front of 7x. There is no sign, so that means that 7x right now is a positive 7x. So how do we undo plus 7x? Well, that means we need to subtract 7x from both sides. The negative sign does not belong to the 7x, the negative sign belongs to the 3y. So we bring down negative 3y, and again, remember my little trick, we're looking for mx plus b, so I'm going to write the mx, the negative 7x first, and then I'm going to write the plus b, the plus 27 second. Again, you don't have to do it this way, this just is a little shortcut that I found. Okay, so now we have negative 3y, he's almost all by himself, but he's still being multiplied by negative 3. We undo multiplication by dividing everything, in this case, by negative 3. So then we have a negative 7 over a negative 3. The negatives cancel out. So we get 7/3 x. And positive 27 divided by negative 3 is negative 9. Okay. Once again, basking in the glory of our accomplishments, we can see that our slope is 7/3. And we can see that our y-intercept would be the ordered pair 0, negative 9. And knowing that, we could then go ahead and graph this equation. Let's do one more example of an equation that is already in standard form. So here we have negative 2x plus 3y equals 6. Again, I'm just going to remind myself, what is my goal? What are we trying to accomplish here? Well, we're trying to get something that looks like this. We're trying to get y all by himself on one side of the equation. So again, we're going to leave the y where he is. We're not going to move him. We're going to move everything else away from him. So right now I have a negative 2x plus 3y. I can undo the negative 2x by adding 2x to both sides. And I encourage you to remember that 6 and 2x are not like terms. You cannot combine them. So we bring down the 3y. Again, I'll use my shortcut to write the mx, the 2x first, and then the plus 6. Again, I'll just save you a little bit of time later. Okay, then we have to get rid of the 3. 3 is being multiplied by y, so we divide everything by 3. So it looks like we have y is equal to 2/3 x plus 6 over 3 is 2. Okay, and again, we can take a minute and pick off our slope. Our slope looks like it's positive 2/3, and our y-intercept would be the ordered pair 0, 2. So if I had to graph it, I would start by plotting the point 0, 2, and then, I could go up 2 over 3, up 2 over 3, or, down 2, left 3, down 2, left 3, just like I mentioned in other videos. All right, let's see another possibility. So there's also this thing called Pointslope Form. So in this particular section, it's not super imperative that you recognize or know Pointslope Form, but I just wanted to show you that an equation could look differently from what we just saw, and you still can achieve this goal of getting y all by itself on one side of the equation. So let's do a few examples of this. So we have y plus 1 equals negative 1/2 times the quantity x minus 2. Again, our goal here is to get y all by itself on one side and to get mx plus b on the other side. So let's take a second and kind of stare at this equation and see how is it different from our goal, right? Where is it lacking? So I see two things personally. One thing that I notice is that there's a plus 1 here. He's got to go away. But another thing that's different are there's these pesky parentheses, right? There are no parentheses in y equals mx plus b. So those are the two things that I want to mess with. So you can do this probably in any order. I feel like the best order to do it, as far as like not making mistakes, is probably to distribute the negative 1/2 first. So let's try it that way. Negative 1/2 times x, of course, is negative 1/2 x. Negative 1/2 times negative 2 is positive 1. So already, hopefully you can see that we're closer to our goal. He's looking more like the y equals mx plus b that we all know and love, okay? I forgot to draw my vertical line. Let me do that. So what's missing now? Well, the only thing that's the problem now is that I still have this plus 1, right? And as always, the y needs to be all by himself on one side of the equation. So that's easy enough to fix, right? We just subtract 1 from both sides, and so we find out that y is equal to negative 1/2 x. Plus 1 minus 1, hey, that's 0. So we could do, we could write it like this if we wanted to. We could also just be lazy and just write y is equal to negative 1/2 x. I would give full credit for both of those. So really quickly, just in case somebody asks you to graph something like this, right? Practice identifying the slope and the y-intercept. The slope is negative 1/2, right? And the y-intercept would be the ordered pair 0, 0. Okay? So that comes from here. All right, let's do a few more examples of this. So here we have y minus 5 equals negative quantity x minus 3. Again, I always write my goal, try to keep my goal in mind. It's always a good idea in life as well as in math. So again, the two things that are not the same as my goal is, one is that the minus 5 next to the y, and the other problem is that I have those silly parentheses. So again, just like last time, I'm going to use the parentheses first. I invite you to remember that with the distributive property, you need to put a 1 here. So you're basically multiplying everything in the parentheses by negative 1, or if you want to think about it as like toggling or changing the sign. So negative 1 times x is negative 1x. Negative 1 times negative 3 is positive 3. Okay, so be careful with those signs. They can trip you up, even the best of us. It's happened to me before, and I've been doing this for years, so just be careful. All right, so then the only other step is to get rid of my minus 5. Get rid of my minus 5 by adding 5. So we have y is equal to negative 1x plus 8. And I think that should be our final answer. And again, I would just remind you that you can very easily, now that it's in slope-intercept form, pick out the slope, which is negative 1, and the y-intercept, of course, which is 0, 8. All right, let's do one more of these examples. So here we have y plus 3 equals 4 times the quantity of x minus 17. Once again, I'll write my goal, because I always like to remind myself, hey, what am I doing? Why am I here? What is the purpose of life? Not really, but it's important to remember what you're trying to do. So just like last time, right, the first thing I'm going to do is get rid of these pesky parentheses that are ruining things. So 4 times x is 4x. 4 times 17 is negative, I believe, 58. Feel free to fact check me on that. So then I'm going to bring down the y plus 3. So just like last time, we'll get rid of that minus 3. So we have y is equal to 4x minus 61. Okay, and that will be our final answer. Again, if you want to take it an extra step and remind yourself that this is useful because it allows us to very quickly identify the slope and the y-intercept, you can do that. So the slope is 4, the y-intercept would be 0, negative 61. Okay, and then of course I could plot. It'd be kind of annoying on a small graph, but you could plot the point 0, negative 61, and then for the slope you would go up 4 over 1 or down 4 left 1. All right, so the last thing I wanted to talk about are special cases. So remember, the equations of vertical and horizontal lines just really don't conform to the y equals mx plus b, right? The horizontal lines do a little bit. You could argue that it would be y is equal to 0x plus b, right? Because basically for your horizontal line, your slope is 0. The vertical lines don't at all because you have x equals something, not y equals something. Remember, your slope is undefined. It's basically like infinity. So you don't have a slope. So what should you do if you run into something that looks like, I don't know, like x equals negative 3 or y equals, positive 4? What should you do that? And my advice to you is, don't waste your time trying to move them or change them around, okay? Don't worry about y equals mx plus b. That's a waste of time. Instead, graph them. They have all the information you need to generate a graph. And if you're like, well, I don't know how to do that, that probably means you have not yet watched those videos on horizontal and vertical lines. So take a minute to watch those videos, and then that should really help you. And then you'll feel much more comfortable and confident graphing equations that might look kind of weird, that might look like x equals negative 3 or y equals 4.